Okay, now we are solving this problem. Now let us think on the problem number 5. Okay, let us think on the problem number 5. How will you solve the problem number 5? These are the 4 problems. Now the same way we can finding the problems number 5. We can solve the problem number 5. We can solve the problem number 5. Let's see in the 5th problem. First, y is equal to tan inverse of 2 raised to x upon 1 plus 2 raised to 2x plus 1. So again we are doing the same job. The job is just simplify the problem. Tan inverse of 2 raised to x is 1 plus 2 raised to 2x into 2 raised to 1. So we can write down this term as tan inverse of 2 raised to x upon 1 plus, this is 2 raised to x bracket square into 2. Okay, now what is our job? Our job is to write down 2 raised to x, 2 raised to x bracket square into 2 is the subtraction of 2 raised to x. Okay, we have to writing the 2 raised to x bracket square plus 2. This is nothing but 2 raised to 2x plus 1. Okay, we want to write 2 raised to 2x plus 1 is the subtraction of the 2 raised to x. So 2 raised to x should be here in the both place. Now let's see, 2 raised to x is there. So how will you write? We want 2 there. We have to 2 there, and 2 raised to x into 2 raised to x, 2 raised to x bracket square. So 2 must be there. So I am writing here 2 into 1. 2 times 2 raised to x minus 1 times 2 raised to x is nothing but 2 raised to x. So y is equal to tan inverse of 2 raised to, in the place of the 2 raised to x we can write 2 into 2 raised to x minus 1 into 2 raised to x upon 1 plus, in the place of the 2 raised to x bracket square into 2 is nothing but 2 into 2 raised to x, 2 into 2 raised to x into 1 into 2 raised to x. So now we can use our formula number second. So y is equal to tan inverse of 2 into 2 raised to x minus tan inverse of 1 into 2 raised to x. So this is nothing but y. We can now use the formula. Say this is equation number 1. Differentiate equation 1 with respect to x. So the derivative of y is dy by dx. The derivative of these 1 upon 1 plus 2 into 2 raised to x bracket square. Take derivative of these because this is the composite function and we cannot be find the derivative directly. So 2 into the derivative of 2 raised to x plus log 2 minus the derivative of these terms is 1 upon 1 plus 1 into 2 raised to x bracket square. Take derivative of these 1 into 2 raised to x log 2. So we can write down these as dy by dx is, take 2 raised to x log 2 as common. Take this common. So 2 raised to x log 2 common. So the remaining term is 2 here. 1 plus the square of 2 is 4 into 2 raised to x bracket square minus here only 1 plus 2 raised to x bracket square. So this is our final answer. Whenever we are going to solve the problem, at that time we have to just manipulate the problem as per given formula. Okay, now in the problem number 6. So what you do in problem number 6, y is equal to cot inverse a square minus 6 times x square upon 5 times ax. What you do here, you have to doing the only one thing. Before that, whenever we are going to solve this type of the problem, convert problem cot inverse into tan inverse. So cot inverse into tan inverse, this problem take only the inverse of the bracket quantity. So here 5ax and in denominator a square minus 6 times x square. Now look at the two formulas, the formula number first and formula number second. In the denominator of the both formulae, the first term is 1, here 1, here 1. So whenever you are using these two formulas, this term should be 1. When we get this term as a 1, yes, definitely we have to divide in the numerator and denominator by this term. So divide numerator and denominator by a square. Okay, so whenever we are dividing the numerator and denominator by a square, what we get? 5 times ax upon a square upon a square upon a square minus 6 times x square upon a square. Okay, so a square get cancelled. Here 1a get cancelled. So the remaining terms are tan inverse of 5 times x upon a square 1 minus 6 times x square upon a square. Now the job of us is same here. What we do? We have to do the 6 times x square upon a square. So the minus sign in between them, here minus sign in between them. So we should be use our first formula. We have to writing xy. Xy is nothing but x plus y. So we have to write 6x square upon a square in the terms of the addition of the two factors. Addition of the two factor, and we are writing 5a upon a square. So if we want 5x upon a square, we should be write a upon x upon a here, x upon a square here, and x upon a square here. So the factor of the 6 is 3 into 2. The addition of 3 plus 2 is 5. X upon a square is the common in between these two. So we can writing 5 times x upon a square is nothing but 3x upon a square plus 2x upon a square. So y is nothing but tan inverse of, in the place of the 5x upon a square is 3x upon a square plus 2x upon a square, and in denominator 1 minus the product of this factor 3x upon a square and here a 2x upon a. Okay, 2x upon a. So the a into a is a square, 3 into 2 6, and x into x is x square. So our x is 3x upon a square and our y is 2x upon a square. So we can use directly this formula, and by using that formula, what you write here, so the final few steps are okay, let's see here. So say we can write this y is equal to tan inverse of 3a upon x plus tan inverse of 2a upon x. 3x upon a. 3x upon a and 2x upon a. So say this is equation number 1. Differentiate equation 1 with respect to x. So the derivative of y is dy by dx. The derivative of this is 1 upon 1 plus 3x upon a bracket square. Take derivative of this. 3 upon a is constant, and the derivative of x is 1 plus the derivative of the second term 1 upon 1 plus 2x upon a bracket square. take derivative 2 upon a is constant and derivative of x is 1. Okay, so we can writing these as dy by dx is equal to 1 upon a is constant, so we can write it outside. So 3 is there, 3 upon 1 plus here 4 times x square upon a square plus 2 into 1 plus 4x square upon a square. So take the product. So 1 upon a, 3 upon, this is a square into 1 a square, 1 into 4x square is 4x square, and 1 into a square is nothing but a square. So the denominator a square I am writing directly in the denominator. So similarly here 2 times a square upon a square into here a square 4 times x square. So 1a is get cancelled from these. So 3a upon a square plus 4x square plus 2a upon a square plus 4 times x square. So this is our dy by dx. So these a get cancelled with one of these a. So finally we got our answer like this. The same problem is here, question number 6. We have to arrange our terms. If we want to use the formula first or second, at that time we should be remember the denominator first term should be 1, and in the denominator this term is not 1, so we should be convert that problem by dividing the proper factor. Dividing the proper factor. Look at the problem number 7. Okay, y is equal to tan inverse of a plus b times tan x. Okay, b minus a times tan x. This term should be 1. So if we want this term as 1, so dividing numerator and denominator by this b. So we can get tan inverse of a upon b plus b upon b, here tan x, and in denominator b by b minus a by b tan x. So what we are doing here, divide numerator and denominator by b. Why b? This term should be 1. So y is equal to tan inverse of here a upon b plus b by b get cancelled, only tan x here, and in denominator b by b is 1, and minus a upon b into tan x. So if we see this problem, then we can able to use the direct formula of first. We can use the first formula in the place of the x, here a upon b, in the place of the y, here there is the tan x. So we can write tan x plus tan y. So this is nothing but tan inverse of a upon b plus tan inverse of the second term tan x. Now tan inverse of a upon b is as it is, plus tan inverse and tan get cancelled and only we get 1. Say this is equation number 1. So differentiate is a upon b. Okay, differentiate equation 1 with respect to x. So we are writing here the derivative of y is dy by dx. This is totally constant and derivative of constant is 0 and derivative of x is 1. So dy by dx is equal to 1. So this is very important problem for the exam. Very important problem. Maybe in your board exam this problem should be asked for the 3 marks. Okay, so the many problems we are covering in our lecture. Now the only 2 problems similar to these are pending. So these are the problems we are solving. This is one of the important problem. in our section. I hope whatever problem I am taking in our whole lecture, you should be understanding very well. Okay, now I am taking the problem number 8 and 9. Okay, I am telling to you how to solve the problem number 9 and problem number 8. Both problems are very easy, and if you understanding the technique how to solve the problem, then you are not getting any difficulty whenever you solve the problem after few months. Okay. Now let's see here. Whenever, again I am telling the same thing, whenever we are going to solve the problem, at that time you have to remember one thing. The thing is, the denominator first term should be 1 in the both formula. Okay, now look at problem number 8. In the denominator there is the 6x square. There is no 1. So what should we do? If there is not 1, then put 1 there. How will you write in that problem? Okay, so y is equal to, okay, just I am changing my pen. It is not properly working. Okay, y is equal to tan inverse of, okay, this is very good. Y is equal to tan inverse of, so here 5 minus x upon 6x square minus 5x minus 3. If we want 1 here, so what should we do? So we can write it as minus 5 minus x. So we want here 1. 1 plus 6x square minus 5x minus 3 minus 1. So here what we do? Plus 1 minus 1. So in this step we add and subtract 1 in denominator. Denominator we have to adding or subtracting 1. So whenever we add or subtract 1, so what happened there? What is happening? Y is equal to tan inverse of, in the numerator 5 minus x, and in the denominator 1 plus, this becomes 6x square minus 5x minus 3 minus 1 minus 4. Okay, so we are taking these all terms in one bracket, plus 1 minus 1. So now we can able to find the factor of these terms. Our formula tell us the product of these terms and sum of these terms or subtraction of these terms. If we are writing plus sign in between 1 plus xy, then we should be write numerator in the term of x minus y. So just try to find the factor of this term, this polynomial 6x square minus 5x minus 4. So 6 into 4, 6 into minus 4, so your product should be 24 and your addition should be minus 5. So we know that 8 and 3, the product of these two terms are 24. If minus 8 plus 3 is minus 5, so we can write here 6x square minus 8x minus 3x minus 4 is equal to 0. So to take the common, so common terms is 3x, so here x minus, so no, there is no any common thing in between them, so what we write there, okay, just expressing this polynomial 6 4s are 24, 6x square plus 3x minus 8x minus 5. Here 4, sorry, there is 4. So take 3 common, here we get 2x plus 3. So take 2 common, so here, sorry, take 4 common, here 3x, 4 and here 2x plus 2. No, something is wrong. x plus 4. 6x square, 6 4s are 24, product should be minus 24, addition should be minus 5, minus 8 plus 3, so minus 8 plus 3, 3 is common, 2x plus, if we take 2 common, 2x plus 1, so take 4 common, so 2x plus 1 here, so the minus sign we are taking common, so the factor of this term is 2x plus 1 and 3x minus 4. Now look, these two factors, if we take the subtraction of these two terms, then we should be get 5 minus x. Okay, let us take the subtraction of these two terms. Okay, quietly jumbling whenever I am solving the factor there. So take the factor carefully and write the proper sign. If you are unable to write these things, then your problem should be in trouble. Okay, so the plus sign in the denominator, so we can writing this term in the subtraction of the two factor. Now let's see here, let 6x square minus 5x minus 4 is nothing but 2x plus 1 and 3x minus 4. So if we take 2x plus 1 minus 3x minus 4, so what you get there? What you get? So 2x minus 3x minus x, 1 minus minus plus 5. So 5 minus x. So we can write it y is equal to tan inverse of, in the term of 5 minus x, in the place of the 5 minus x, we can write here 2x plus 1 minus 3x minus 4 upon, in denominator 1 plus, in the place of these we can write here 2x plus 1 and 3x minus 4 product. So say this is equation number, before use formula number second. So you got here tan inverse of 2x plus 1 minus tan inverse of 3x minus 4. Now say this is equation number 1. Differentiate equation 1 with respect to x. So the derivative of y is dy by dx. The derivative of this is 1 upon 1 plus 2x plus 1 bracket square. So take derivative of this because it's a composite function. Tan inverse of fx formula should be used. So the 2x is constant, 2 is constant, derivative of x is 1 and 1 is totally constant, its derivative is 0. Minus 1 upon 1 plus 3x minus 4 bracket square, take its derivative. 3 into the derivative of x is 1 and derivative of 4 is 0. So finally we can write here dy by dx is equal to, so 2 1 plus 2x plus 1 bracket square minus here 3 into 1 plus 3x minus 4 bracket square. So this is your final solution, final answer. Okay, whenever you solve the problem at that time, just remember one thing, try to find out the factor carefully, and one of the most important thing, try to add, whenever you are writing this polynomial, add and subtract 1 in the both, add and subtract. If there is a plus sign for x square terms, so 1 plus, you should be write the 1 plus and minus 1 after this polynomial. If the minus sign, if here minus sign, then you should be do opposite thing. Okay, so let us see this problem, the last problem of today's session. Y is equal to, the last problem of today's session. I hope that you have to enjoy our total session. The last problem, 9th problem. Y is equal to cot inverse of 4 minus x minus 2x square upon 3x plus 2. Okay, so we can converting this problem into tan inverse. So 3x plus 2 in numerator and 4 minus x minus 2x square in denominator. Okay, let's see here. Now, if there is minus sign to x square, then here subtract this polynomial into 1 if there is the plus sign for the polynomial. Okay, let's see. After solving the problem, we are writing the two rules how to solve the problem. Okay, y is equal to tan inverse of. Now let's see here 3x plus 2, and we have to subtracting the whole polynomial in 1 and plus add plus here. So here 4 minus x minus 2x square plus 1. Okay, in the first problem we are to writing 1 plus, in the second problem we are to writing 1 minus. Whenever the minus sign to x square coefficient, then you should be subtract the whole polynomial from 1. If there is a plus sign to x square coefficient, then you should be if it is a plus sign, then you should be add 1 plus that polynomial. So now this polynomial looking as y is equal to tan inverse of 3x plus 2, and in your denominator 1 minus, so give the minus sign to this polynomial, 1 minus 4 plus x plus 2x square plus 1. Okay, now minus 4 plus 1 tan inverse, this minus sign outside the bracket changes the whole sign. Okay, so 3x plus 2 upon 1 minus, take all these quantity in the one bracket. If we are taking, okay, sorry, here 1 minus sign, 1 minus, okay, so the minus sign should be there. So take the all terms in single bracket. So what do you do there? One minus, I think quite wrong the problem. 1 minus 4x square. Plus, that is fuel error